All right, we just finished solving our first quadratic inequality, and we have a graph of our solutions. And I want to show you why this ends up being our solution. I know that we went through the solving the corresponding equation and the sign chart and everything, but I want to give you a visual explanation of why that is the case. So what we just did was we looked at x squared minus 6x plus 8 is less than or equal to 0. I want to look at something that's different but very much related to this. I want to look at y equals x squared minus 6x plus 8. Now this ends up being a quadratic equation in two variables. We know that if we graph it, we end up with a parabola. And I want to do a very quick sketch of what this is going to look like. So we will need an XY plane. Now to graph this, there's a few things we usually do. We find the vertex, we find the X-intercepts, we find the Y-intercepts. I'm going to skip the vertex here because we don't need a perfect graph. We just need a sketch. So I want the X and Y-intercepts. The Y-intercept is pretty easy. We know that that's the constant term. So the y-intercept is going to end up being 8. The x-intercepts are the solutions to 0 equals x squared minus 6x plus 8. However, if we look over here, we have already solved this, and we got x equals 2 and x equals 4. So in this case, 2 and 4 are going to end up being our x-intercepts. Also, we know that this parabola is going to be opening upward because we've got a positive leading coefficient. So I'm just going to do a very quick sketch of this parabola. And I'm actually going to do it in a couple of colors, and I will explain why in just a moment. But let's sketch this. We know it's going to go down, and then I'm going to switch colors just for a moment. And then it's going to be going back up. We know the graph is going to look like that. Beautiful. Now I want to point out something about the different colors that I used. I used red specifically for the part where the graph goes below the x-axis. Now when the graph is below the x-axis, this is when y is less than 0. These are the y values that are negative. But if y is less than 0 and y is equal to x squared minus 6x plus 8, that means that x squared minus 6x plus 8 is less than 0 in the red area. And that's why our solution ends up being the interval between 2 and 4, which we see over here, because that is where the graph goes below the x-axis, which means that's where the y values are less than 0. And then if we look at the blue part is where all of this is greater than 0, because this is where we're above the x-axis, this is where the y values are greater than 0, and specifically this occurs for values that are greater than 4 and less than 2. So if we wanted to shade in the part of the number line where this is greater than 0, that would be the outermost intervals. It's not the most beautiful shading, but there you go. So anyways, what we're doing when we're going through the process of making this sign chart, when we solve the corresponding equation, we end up with the points that are our x-intercepts, and these are the points where that expression is equal to 0. And then on these other intervals, the ones on the outside and on the inside, this is where our parabola is either above 0 or below 0. Above the x-axis or below the x-axis, which means that's when we're greater than 0 and less than 0. So once we find the solutions to this inequality, that gives us the points where it's equal to 0, we just need to figure out what's going on in these other intervals. Are our values bigger than 0? Are our values less than 0? And in fact, I'm gonna do something that might seem silly. I'm gonna draw a sketch of a parabola here. Because the parabola goes below the x-axis in the middle, its y values are less than 0, which means its y values are negative. So this negative here is telling us the y values are negative, and so the expression is less than 0. And then these positives are telling us this is where the graph goes above the x-axis, this is where the y values are positive, and that means this is where this expression is greater than 0. Since we specifically wanted to know when it was less than or equal to 0, we shaded in the middle. If we were doing a different problem where it was greater than or equal to 0, we would be shading the intervals on the outside. So that's just a little bit of a graphical behind-the-scenes explanation of what's going on. I hope that made a bit of sense. Please go through some of the other examples because you will see some where we're looking at greater than 0. We'll have some greater than zeros, we'll have less than zeros, we'll have less than or equal to, we'll have greater than or equal to, so you can look at all of the different possibilities.